Hi, and welcome to our discussion of anemometry. In this section, we're going to talk about how wind direction is measured. And specifically, we're going to look at three different types of devices. We'll start out with the wind vane. So the wind vane, as you can imagine, is an instrument that's, of course, used to measure wind direction. There's a picture of a wind vane. And there are different types of wind vanes, and we'll talk about those in a little bit. But first, we're going to look at how a wind vane performs. In other words, how it responds to wind direction. So the first part is static performance. We're going to talk about how a wind vane actually measures its direction. And after that, we'll get into how a wind vane measures direction over a period of time by discussing its dynamic performance. So with static performance, in other words, how does a wind vane do its job? Well, of course, it orientates itself into the wind, so it's pointing in the direction that the wind is coming from. And there's got to be some sort of device to measure that. You can, of course, use your eye to estimate the direction of the wind, but we would like to record that data and also get a little bit more accurate measurement. So we use, of course, electronic circuitry. And one of the devices that helps us measure the wind direction is called a potentiometer. And what a potentiometer is, it's, of course, a device that measures electrical potential, as the name implies. What it does, a current is sent through this device. The device has a shaft that's allowed to rotate, and that shaft is connected to a variable resistor. So as it changes, the resistance changes, so the current and also the potential or the voltage changes. So based on the varying voltage, you know what direction the shaft is pointed. So of course it depends on the direction of the wind. You'll have to calibrate it to figure out the voltage for whichever direction that it's pointing, and then reference that to true north. Here's a picture on an aero vane that we have in our lab. It shows the connection between the shaft. As you can see, it kind of looks like a shiny part coming out of the main wind vane. Comes down and it's connected by actually gears, and the gears are driving a potentiometer. So based on the direction that the wind vane is pointing, you can figure out its direction with respect to true north. So some problems with calibration, or some problems with static performance. Perhaps the wind vane is not pointing in the proper direction. When you calibrate it, you have to actually break out some sort of reference to figure out which direction north is, true north, not magnetic. And based on that, calibrate the wind vane or the potentiometer so that you know what voltage is true north. So that's one problem, setting it up. And that is a problem, actually. I was on a project a number of years ago where they actually had set up not a wind vane, but a radar. They set it up 180 degrees out of sync with the direction. So we were watching thunderstorms moving in from the south, and they were actually moving in from the north. So that is a concern. The other thing is the wind vane may not be balanced properly. If that's the case, then it will always be pointing or biasing towards one direction. So it needs to be balanced properly. At some airports, actually many airports, they have devices that show you the direction of the wind, and some of these devices, called tetrahedrons, actually point in the direction of the runway that they would like you to land on when the wind is very light. So it is actually purposely unbalanced to point a direction for the calm wind runway. We're not too concerned about that here. We just want to know the direction of the wind, so we want to make sure that it's properly balanced. So That is static performance for wind vanes, and we'll cover dynamic performance in another video.